Already? Happy Thursday, right? Yes, Thursday. All right, we've got not too much to tackle today, actually. So we're going to finish up talking about classes. I want to look at unit tests and talk just briefly about UML class diagrams. And we're going to use all of those things in the first project, which then we'll talk about. So a little bit of new stuff, then talk about the first project, and then hopefully it'll be a little bit of a shorter day, and then we can get going from there because, yeah, it should be fun. So when we were working on our classes here, we had all these different polygons and nothing super exciting. Oh, that's the wrong program. PyCharm. One of these days, I'll remember what I'm doing. PyCharm. I'm not on mute, am I? Oh, and you wanted a dad joke, Funkelman? You got it. You've got channel points you can use if you follow along. At what time did the man go to the dentist? 2:30. So it's kind of a mean joke because I know some people don't like the dentist. I've always had a good experience, and it's crazy. I moved to this area from New York when I was 7, and I've been seeing the same dentist ever since. No, I'm not super old or anything, but like, it's just kind of cool. I was his very first year that he opened his practice. I was like one of his first patients, so the guy still remembers me, which is fun. So I like the dentist, but not everyone else does. All right. So we've talked about, yeah. Yes, change screens on the screen you guys can see. Thank you. There we go. How's that? Thank you. I'm sorry. That's much better, isn't it? Okay. So I mentioned like we put some input in and we look at what comes back out and we say, okay, is this what I expect? This is I think I call it poor man's testing. That's sort of my joke for it here, because if you've ever written an English paper, you know people are really bad at this sort of thing. Like I know what I meant to say when I was writing my paper, and I go and proofread it, and I totally miss that I said the word "the" 3 times in a row. Because in my head, I know what it's supposed to say, so like I'm not actually paying all that much attention here. So the right way for us to do testing is to make the computer do it. Because the computer, if we tell it, hey, look for this given output for this given input, we'll make sure it matches. And that's what we're going to take advantage of. And that's what we're going to call unit testing. So in terms of testing software, there's all sorts of different scales of how large tests get to how small tests get. And generally, unit testing is the smallest scale test that we'll do. So a unit test focuses on one small unit of code, generally even down to a specific function. That's about the smallest unit of code we can test, because the function has some input and has some output. That's generally what functions do for us. They vary ever so slightly for things, but get area. I should, for a given polygon, know what the area, or I'm sorry, for a given rectangle, I should know what the area is, because I told it what the lengths of the sides are. So I'll know what the area is. So that's easy for me to say, given this input, I expect this to come back out. And that's kind of what we did. And I mentioned it, and I just kind of, okay, if I told it it's a 4x5 rectangle, I should get 20 back out. And then I get confused because perimeter is not area. And sure, things are hard for people sometimes. So what we want to do is we want to take advantage of the computer's ability to check this for us with unit tests. At a higher level, and the more you get into software engineering, there's other levels of testing. We can start doing integration testing. And does my code integrate with other code? So when my code asks other code to do something, does it give me the correct result? It's bigger than just one small unit of code here. So it's a larger test. You also have system testing where you're testing the entire system, and you have end-to-end testing where you're testing the entire system from, all the way down to this level, all the way out and back. And depending on what our software is doing, these tests can get complex. So unit testing is quick, or should be quick, and it should be easy to do, and it should give us some confidence that our code does what it's supposed to do. And it also should give us confidence that it does not do what it's not supposed to do, because that's also bad, right? It's bad if it doesn't do what it's supposed to do, but it's bad if it doesn't do the things it's not supposed to do. So just because it does it right when we give it good things doesn't mean that it's working properly and functionally. So we looked briefly at, hey, which one of these here? If my length was less than 0, we're going to throw an exception, raise an exception, because this is just invalid for my object. So I need to make sure that my object maintains its integrity. It's one of those core concepts of object-oriented programming, is that my object, I'm going to encapsulate all the details about my object into one nice little package here, and it will maintain its integrity of its attributes. So you should not be able to set an invalid side length unless you do something bad, like go access this private value directly. Which, again, if you're accessing private values directly, all bets are off because you voided the warranty, right? Like once you open up your cell phone, they're not giving you the warranty anymore. That sort of deal here. So same idea with Python code. If you go change the private values, well, that's on you. But if we use it as advertised, it should do the things it's supposed to do. So when we do our object-oriented programming, we protect the integrity of our class. We make sure that our attributes are good and valid and useful. And then we're going to make sure that for given inputs, we get the correct outputs. So the easy way to do that here, let's start with Polygon. I'm going to come to the Polygon class here. I'm going to right click on it and I'm going to say go to test. So you can do these other ways and you can do them by hand, but I'm a big fan of the tool writing code for me, or at least getting me started here. So I'm going to right click on the name of the class and say go to test. And it's going to say, oh, we don't have any tests. And I'll say, yeah, okay, that's fine. I want to make new tests. So make new tests is great. It gives me all sorts of cool options here. Usually you get test and then the name of your module. So because my module is named Polygon, or my file is named Polygon, I get a test Polygon file. And then the name of the class is test, and the name of the class I'm testing, Polygon. Okay. If you put all of your classes in one module, you'll have one big test module as well. That's okay. Again, I'm partial to the one class per file. It's just the way I've been doing things. It's the way I like looking at things in source control, but it's not the only right way to do things here. And then it says, what do you want to test? Well, I really want to test everything. So you can start checking these boxes here and say, hey, test this function, test this function, test this function, test this function, because unit tests generally test one function at a time. So the tool says, hey, do you want to test these functions? We say, yes, please. And then we get some starter code here. So from here, we are using the unit test module that comes in Python. We're using the test case class, right? This other syntax for doing our imports here. We write our own class, and you notice it inherits from the test case class. So because we are an instance of test case, we have a bunch of methods and functions and things we already know how to do, which is really nice. So some of those things like fail probably are not very exciting, but they will fail the test. So what happens here is I can go and run this file here. I can run my tests, and then I get this really cool test explorer here. And it says, hey, I ran some tests, and by the way, these tests fail. They get some big red X's here. If they pass, you get big green check marks. So it's useful if you're colorblind because you get check marks versus X's here, and you get the visual cue for people who like colors. And then you can click on each individual test, and it just says fail. There's nothing interesting here, but we'll go fail them in here in just a second. So what we want to do when we write our tests is set up the code we're testing, run the code we're testing, and then see if we got the right results. There's a convention for this. It's not a rule. It's just a way that people like to do this. It's not the only way, but I'm partial to this, so that's what I show. It's called the AAA format. This is our AAA convention here. So we're going to arrange the code we need. We are going to test. Arrange the code we are going to test. This is set up the variables we need. And then we're going to act here. So arrange, act is call the code we are testing. And then we're going to assert, did we get what we expected? Okay, just like we did in our main function, right? I said, hey, here's a square, or here's a polygon. It has 4 sides. So I'm setting up some code, and then I'm calling the code. I'm setting my side lengths, actually using the code we're testing here, and then I'm getting the perimeter back out. And I just eyeballed it and said, okay, I expect the perimeter to be 40, because if I have 4 sides of 4, it should be 40. Right? We're going to do the exact same thing here in our code. So we're going to arrange. So what we do is we set up the variables we need. So I need this one we're just testing number of sides. Okay, we'll focus on number of sides first. So I need a polygon to test. So here's, some polygon will equal, we got to import polygon, right? So from polygon, import polygons, we can use it, equals a polygon of how many sides? So we probably need, we could just put like 5 in here. Remember, we don't usually like just putting numbers in our code because they don't have names. We don't know what they mean here. So I'm going to say this is my expected number of sides is 5. So we're going to follow this format where I have expected values and I have actual values. The expected is what I think I should get, and the actual is what the code tells me that I got. So then I can say, okay, let's make a polygon with the expected number of sides, which happens to be 5. We'll make a pentagon, right? Sure, that's my arrange. So I've set this up here. Now I need to call the code. Well, what code are we testing? We're testing the get number of sides function here. So I'll have an actual number of sides equals my sum polygon dot get number of sides. We'll call the function. This is the function we're testing, right? Because I want to see, can I get back out the number of sides correctly? It's not a very interesting test, right? But it's small. We got to start somewhere to make sure it does what it's supposed to do here. Okay, and then we assert. Did we get what we expect? We say self dot assert. Now there's a bunch of different asserts here. Most of the time we're just going to use assert equal. Sometimes we'll use assert true. You can use assert raises if it's supposed to raise an exception. There's all sorts of amazing things we can do with these. If it's in, check for dictionaries. If we're doing with floating point numbers, you can say it's almost equals and like, hey, how close is close enough? If we're within, 10 thousandths here, are we close enough? Because remember, when we do floating point arithmetic, every so often we get a really weird rounding error and we get like 15 decimal places of nines because computers are bad at math sometimes. So usually equals here, and we'll get to all these different examples here, but equals should do most of it here. And then we get our expected number of sides and the actual number of sides. We'll say, hey, I am asserting these things should be equal. If they're equal, my test will pass. If they're not equal, my test will fail. So let me just give you one that fails first here so you can see that it fails and see the output. So if I expect to have 5, but I gave it 4, I shouldn't pass this test. This one should fail, right? So when I go run this test, I can say run the test here, and I get a failure here. And when I click on it, it shows me, hey, you expected to get 5, you actually got 4. So even in my test viewer here, this little test output, it gives you some really good feedback right away. And you see, hey, the name of the test get number of sides failed. So by naming things nicely, using the expected values and actual values, we can see really quickly that it didn't do what it was supposed to do, but we expected that. So now let's fix it and run it again here. We'll go run, and now we see the green check mark, it passed. There's no output because it passed. There's nothing for me to look at. You only get the output if it fails. So this test now passes. If I tell it has 5 sides, it's now a 5-sided polygon. Life is good. So a lot of times these get ones are kind of boring to test, and I don't like testing the gets all at once. What I will generally do, which is my sort of way of cheating here, is I'll have a test constructor or test init, like test polygon init here. And in test polygon init, right, most of the time our init methods, the constructors, the way of initializing our objects, their job is to give values to all these self attributes here. So in this case, we'll have a number of sides, we'll have side lengths, we'll have a name. I'm going to test all of them at once because this is still basically one unit of code. Some people will argue with me, and that's fine. That's if you want to go test individual gets, go for it. I don't care. I think at that point we've done more work than we needed to. But if we test our init method, we can also test then the get number of sides, get side length, get perimeter, and make sure the name is set. Right? We can test all of them all at once. Right? All the gets essentially. Well, maybe not perimeters here. Yeah, we'll have to do side lengths first, but we can test the number of sides and name, right? Kind of both at once. We don't need to do them separately here. So I'll have this. So I'll arrange. So basically, I'm going to do the same thing here. Just copy these in, but I'm also going to give it a name. We'll have an expected name is pentagon. We'll make this here, and we'll give it pentagon, our expected name. Right? So you can tell the number of sides and the name, and then we'll get an actual name is my sum polygon.name. Again, we opted not to have a get method here because we didn't really care what name was, but it's an attribute. So I want to make sure that things are happening the way they're supposed to, because when I'm writing my code, sometimes I type the wrong things here and I don't get self name equals name. Sometimes I might say like name equals name, and then I've really screwed things up because then I don't have a name property and just stuff isn't going to work right. So it's still useful to test these things. It feels a little silly sometimes, but it's still useful. And then you can have more than one assert. So we'll also assert equals then my expected name and my actual name. You just list all the things we're asserting here just in a row. The first one that fails, the test will fail. So if you have 15 different asserts, as soon as one of them fails, it never bothers looking at the rest of them. Just for what that's worth, you can keep that in your back pocket. So now we run our tests. We get the test polygon init passes. We get the test get number of sides passes. Again, I'm just going to go and we wouldn't do this one usually because I would just do the test init. And that's when you are working in project 0, I just need test inits and then test all the functions that actually do things here. So the next one is interesting is like set side length. This is a good one to test here. So we can actually save a lot of this here, right? Because a lot of it starts the same way. There's some cool shortcuts you can use that I'm not going to bother with because they usually confuse people, where like if you always do the exact same thing, you can make a separate function that your test functions call this function to do this thing. It's really good, but often confusing. So I'm going to copy paste some code and feel bad about it, and that's okay. If you want to make a function that gives you a polygon, go for it. You can put that in your test file. It's code, right? It's more code to test our code here, but again, up to you, however you want to do this here. So set side lengths here. We'll have, sure, we can do 5 number of sides again here. Now, I don't care about the actual number of sides here, so I don't need to do any of this in act here. What I'm going to have in here is an expected perimeter, because when I set all my side lengths, I should get back a perimeter that is the sum of them here. So if we do like 1, 2, 3, 4, 5, that should be, goodness, I can't do math. No, if we do 1, 2, 3, 4, we should get 10. So let's do a 4-sided shape here with a perimeter of 10. Okay. So we'll make a 4-sided shape, give it some side lengths here. So when we set the side lengths here, we can say for, I don't know, side index in range. Let's go 1 to, I guess we can just do range 4, because this will give me 0 and then 1 and then 2 and then 3, which are the indexes here. I can say my sum polygon.set side length, given the side index, and what value do I want to set it to? I'm going to take the side index plus 1. So this way I don't have a 0 length. I'll have a 1 length and a 2 length and a 3 length. I just wanted to do a loop. You could just have 4 different lines of code here. Would it be easier to just do 4 lines of code instead of a loop? We can do either one. Like you're welcome to just punch it in yourself too. It's just code, right? Any way we want to do this is okay. So we could say 0 and 1, and 1 and 2, and 3 and 4. Like either way, perfectly fine. Any way you want to do it. That's just a duplicate here. Duplicate, for example. Perfectly fine, right? We're testing set side length. It's okay. You can use any of the same coding shortcuts you use because we're still writing code. This is why tests are amazing. Okay. Then what I should be able to get back out then is the perimeter. I could check get side length as well. I'm not too concerned. I think getting the perimeter out will be okay in here for that. So we'll have an actual perimeter. Perimeter is my sum polygon get perimeter. We'll get the perimeter and then we'll assert, does the actual perimeter match the expected perimeter? If you double click on a word in PyCharm, it'll highlight the whole thing. It actually does this for basically any text editing. Double clicking will grab it all, and the underscores count as regular characters. So I can double click to highlight something, and I'm doing Control-C for copy. I do a lot of shortcuts, and I apologize if I just don't mention them. So I tried to the first time or two, but cool. So if I set a bunch of side lengths, I should get the right perimeter back out. It works. And then the other fun thing you can do is you can debug your unit tests. Just like you can debug your main code, we can run this in debug mode instead of run it and actually step through and say, hey, let me see what happens when this function is called. So if it's not working right, we can step through and see 1 line at a time what's happening. So we really did get perimeter and get side length at the same. We didn't do get side length, but it's kind of included. I feel a little bad, but it's all happening. If we wanted to, we could also check get side length. We could. Okay, why not? Why not? So in our act section, then we'll have an actual side 0 length. Should we make a list of side lengths? That might be easier. Make a list of side lengths. So this would be actual side lengths equals a list, and then for index, side index in range 4. We'll take our actual side length and we're going to append my sum polygon get side length of side index. So I'll go get out the 4 lengths here, right, of 1, 2, 3, 4. And then we can even assert in a loop, right, if you want. So we'll do it again. And we'll say how about range, we'll say for side length maybe, how about that, for side length in side lengths, actual side lengths, we can assert. I guess we need 2. Okay, so we'll do 1 more here then. We'll make an actual expected side lengths. 1, 2, 3, 4. Oh, okay, now we can just compare the match, even easier. We'll say self assert think we can use list equals. Here we go. So assert list equals. The two lists have equivalent values here. You can say my expected side length, my actual side lengths. All right, so now we're testing the get side length as well, and I feel a little better here. And it passes. So when we're doing our testing, there's a thing people use to measure how much code you're testing. It's called code coverage. PyCharm will do it with the paid version, I believe. It'll actually go through and say, hey, you have 20 lines of code in your Polygon file. When these unit tests run, this many of these lines of code are actually being ran because it can see what's happening. So this line of code runs, this line of code runs, this line of code never ran. So if I were to look at that metric, that measure, I don't have 100% code coverage. Not 100% of my code is running while I'm testing. And that's sort of the gold standard. It's a little bit tricky to get to, and some organizations say it's not really worth your time to get to 100%. Just get to some good number of tests is better than no tests. Because like many things, there's this diminishing returns. Like we get paid to write software. We get paid to write working software. So we want to test our software to make sure it works. But if I'm spending more time testing it, they're going to start getting upset with me. Right? They're like, just give me the working software. And I'll say, well, I need to make sure it works right. And they're like, well, you could spend infinity amount of time saying, hey, what if length is -1? What if length is -2? What if length is -3? What if length is -4? This is a bad example for that, but you can test and test and test and test and test till you go crazy here. We're just going to test once here to make sure that, yes, this line of code will run. We feel pretty good because it looks like it's a less than 0 sign. It's probably good. So just because we've tested our code with unit tests doesn't mean it's perfect, doesn't mean it's bug-free, doesn't mean it won't have issues, but it'll be a much higher quality because we've had now essentially made the computer check it for us, saying, if I put this in, I get this back out. And the computer will do it as often as we want it to, and it does it really fast, which is nice. So as I build up all my tests here, I can have a bunch of different tests, right, for each class, and I can run all of my tests right away. I can run them. And the next cool thing you can do once you have unit tests is you can use your source control tool, like GitHub has all sorts of cool triggers and actions built in to say, hey, when you commit code to your repository, go run the unit tests for the person. So in large organizations, when people work on software, when you check your code into source control and say, okay, hey, I did some stuff, I'm going to go check it in, all of those thousands and thousands and thousands of tests that people have written will go run and make sure it still does what it's supposed to do. Because it's easy to break things, right? You change a sign around and you can break something. So we can run all the tests automatically. That's known as continuous integration testing. As we integrate code into source control, it gets continuously tested. If you can do that, the next step that can happen, and again, sort of depends on what applications you're working on, but you can move to continuous deployment. So the actual GitHub website itself runs on continuous integration, continuous deployment. When developers there make changes to the GitHub website, it runs through the test, and if the tests pass, it has an automated process to go and update the actual live running website. So a developer, in the matter of a couple hours, can do something, test it, make sure it works, and get it up and running out in the live website in the real world for people to use. That's continuous deployment. It's fantastic. It reduces the turnaround time, makes people more efficient, productive, easier to make changes, more agile, and businesses generally think the faster we can change things, the better. Which is usually a pretty true statement. If it's like, hey, I need a change to this piece of software, you're like, okay, that'll take 3 months. Like, okay, this sucks. I mean, how are we going to actually know if the change is good? How do we try this thing? So that's the goal in a lot of software organizations is to be able to get code quickly out to users to use it, out into production, out into the working system. So by having a suite of tests, we have relatively high confidence that things should work. And again, just unit tests is not really enough. There's a whole range of tests that we would do, and all of that can be automated. If we can tell the computer what to do, it can run it for us. So we build our unit tests. On top of that, we build the integration tests and the system tests and end-to-end tests, and all of those things will run, and then stuff just works. So I have friends who who work at Khan Academy now. They have the same system in place. If you've ever used Khan Academy, any of their web developers working on their website can go and make changes, push it, and then the automated process will go and make the code live on their website. So they can quickly get changes out for people, which is awesome. It's a great process, and it's all done with code because code is amazing. So that's unit testing. That's talking about code coverage. We're not going to pay for anything here because we just want the free tool. So we're going to eyeball that idea of code coverage. So I'm going to say, hey, how much code actually ran when I did my init? Well, I used the get method here for get number of sides. So, okay, the init method ran and my get number of sides ran. Right, and I also tested my side lengths. So when I did side lengths here, I used my set side length function. This didn't run yet. I didn't try it. We'll come back to this later. I don't want to spend a whole lot of time on it right now. We'll practice this in lab, catching exceptions. It's like 3 extra steps. It's not too bad, but I just want to skip it right now if that's okay with you. So this one ran, and then we did the get side length, and we did the get perimeter. So I feel like every line of code except this one has run. So in terms of code coverage, I'm almost at 100%, not quite there, right? And we're just eyeballing it. Okay, so for the project, when I say you need to have unit tests, and that's in the, I didn't add the document here. Hang on, I got to add the link to it. Insert link, course document. There it is, Trek Wars. Not to be confused with Star Trek or Star Wars. These are completely different concepts here. So the idea with the project is we're building classes. We're just doing our small portion here. We're not building a user interface. We're not building the game portion here. We're just building the logic that other people can take and turn into an interesting game here. So we're building this totally unique space battle game, never been seen before, called Trek Wars. We have to make the classes for it. We're going to write the classes and test it. So we're going to make some classes. We're going to use this idea of an enum. I'll show you those in a little bit here. They're really easy. It's just putting a name to something. We're going to make a class called ship. This is our base class. It'll have a bunch of attributes. It'll have a name. It'll have an alignment, which is of this enum. So there's 2 teams and then the chaotic people. So us is the us team. Them is the them team. And then chaotic people just fight everyone because they're nuts. So that's what it is. So the 3 teams, the third team is not really a team, is your alignment. You'll have a location. We're going to imagine this as a 2-dimensional grid because space hurts my head and I can't deal with 3 dimensions in space. So just 2 dimensions, just an X and a Y. Forget Z because life is easier this way. Which I watched some video about our solar system. Like we're not actually all like spinning in a good circle around the sun because we're also traveling around the galaxy. And it was like a really cool spiral visualization, which was awesome. But that is just complex. And then someone mentioned if we ever could figure out time travel, we also need to figure out space travel because not only do we travel in time, but the location of where our Earth is in a different spot in the solar system depending on when it is. So maybe people have already figured out time travel and they just haven't figured out the space travel yet. But that was kind of a joke. I don't know. Sorry. You'll have a range. So your ship has a certain range for its weapons. How far out does the weapon reach? Right. It'll have a current health. So your ship can take so much damage before it blows up. Okay? You'll have an attack power, is how much damage you do when you attack another ship. And then you'll have a max health, is what was the maximum possible health that this ship could have. That's our ship base class. So we're going to start inheriting from ship in just a minute here. So we'll have some different methods. We'll have an init method that takes just about everything here. Now, it doesn't take a current health. So when you make a brand new ship, its current health should be set to its max health because it's a brand new ship. Shouldn't have any damage, right? So there's no argument here for the current health. You give it the name, you give it the X, you give it the Y, you give it the alignment, you give it the max health, you give it the range, you give it the attack power. And I've included this colon notation. Some people are starting to do this in Python. You can technically tell Python I'm expecting an integer. I haven't seen it become super common. It's technically valid, but I never use it. But so you can like X location, Y location should be integers. This is more just an indication for you, and we use this notation in UML diagrams, which we'll talk about as well. So this is just the type that I expect these things to be. Like you don't just copy paste this line into PyCharm, right? This is to give you some additional information here. And then you'll have a function for attack that takes a target to attack, which is another ship. So one ship will attack another ship. So here's the target. Here's who I'm going to attack. You'll have a get type, which returns the type of ship. So we have some different subclasses we'll talk about here in a minute. It'll be a battleship, a cruiser, a corvette, or a repair ship. A get X, a get Y, a get alignment. These are not very interesting. Those are just gets. We'll have a status, which returns a particularly formatted string. Here, it's got like all the information about ship in one nice string for us to look at. And then we'll have a move function. Move ships don't have a direction that they move. The base class doesn't. But what happens is you increase your health by 1, but no more than max. So every time you move, somehow you get healed in space because it's magical. Just go with me here. It doesn't have to make a lot of sense. We'll have a change alignment that changes us to them to us, or if you're chaotic, you just stay chaotic. You can't change from there. So it'll flip us to them or them to us here. And then we'll have an assess damage that reduces the health, but it has to stay within bounds of 0 and max. So you can't go to negative health. You just 0 and you're blown up. Right? There's no like negative health bar range. Your ship is destroyed, or max is the most here when we assess damage. That's the base class. Okay, so then the first class we're going to write that derives from ship is the battleship class. Its range is 10, its max health is 100, its attack power is 10. It also, what makes it unique is it has torpedoes. It starts with 10 torpedoes. So when a battleship moves, it will always move at -1, -1. Again, doesn't have to make sense. This is supposed to make things a little easier so that you don't say, hey, I want to move this direction. We'll just, when you call move, it goes this direction. Because sure. It just always goes that way. And then it will still, because it is a type of ship, gain its 1 health. Right? Both these things should happen. So the superclass version should happen and my special version should happen. Right? We need to make sure we're doing both. And then when we attack, you can do an additional 10 damage if you have a torpedo. So some additional logic in this attack here is that if I have torpedoes, I do +10 on top of my 10 attack power. And this is if they're within range. So this idea of range, right? You have to figure out your X and Y coordinates, their X and Y coordinates, figure out the distance between 2 points. You folks are in at least Calc 2. I trust you can do that to see if that is within range. So if your ship is not within range, right? You have this range attribute. This is your max range. It doesn't do any damage to the other ship. You shoot your laser beam off or whatever, and for some reason they dissipate in space, or I don't know what happens in Star Wars land, because it seems really scary. Like if everyone's shooting laser beams around in space, they should just go. Right? Like, what happens like a year from now if you're flying down? I don't know. It's the kind of things that keep me awake at night. I don't know why. So attack and then status will also then include the number of torpedoes in the battleship status. So we're going to have to add additional information to status. The cruiser comes from ship. It has a range of 50, a max health of 50, an attack power of 5. It moves this direction of 1, 2 instead of -1, -1, and then it can attack ships. There's nothing special that it does here aside from that. So it just has some fixed attributes essentially here with cruiser. We'll have a corvette. Corvettes are different here. They have a different range, different health. Their attack does something completely different because everyone loves corvettes. They will turn ships to their side. So if a corvette ship with an alignment of us attacks another ship of an alignment of them, now the them ship is now on team us. We've changed alignment. If they're chaotic, nothing happens. We can't change them because they're just nuts here. And then if it's another us ship, don't change their team, right? If you're on team us, they don't change another team us ship. So us only changes thems. If they're on team them, it should only change team us. Right? So this change alignment idea here is if it's the other type, change it to my type if they're within range. They don't do any damage. They just fly around and make everyone love them because corvettes are cool, I guess. Okay? And that's the change alignment function that we wrote. Then we'll have a repair ship. Notice this one derives from cruiser, not from ship itself. So we're going that next level of inheritance. So a cruiser is a ship, a repair ship is a cruiser. What makes repair ships different is attack repairs ships, like a repair ship. So it will put its health back to max health if it's on your team. Right? Don't repair other team's ships. Chaotic ships, or team chaotic won't have repair ships because if you're chaotic and want to attack everyone, you're not going to repair anybody. So just pretend like you don't even need to worry about that in your code. It won't happen. So us repair ships will repair team us ships within range. Team them repair ships will repair team them ships within range when we call this attack method. Okay? So in terms of any input, there's no actual gameplay. There's no input that happens here. Nothing goes in because all we're doing is building the classes and writing the tests. Does it do what it's supposed to do? There's no actual game to play. And then for output, the status function should return the name of the ship, the type of the ship, the health of the ship, the location of the ship, and then if it's a battleship, its number of torpedoes, all in one string. The idea like someone could take this and put it somewhere, whether or not we want to build a web application or a mobile application or a desktop application or whatever we wanted to do here. Someone else can turn it into a game, right? We're just working on the classes here. Okay. Just another note: the only works if they're the opposite alignment and within range, except for repair ships that work on the same team, right? Us attacks them attacks us, chaotics attack everybody. And then we're going to build UML diagrams of our classes. So we're probably actually going to do this in lab because the Visio tool is the better tool for this. I'll show you the cheap version here. It's not very interesting. I just draw pictures in Word because it's easy. But Visio is a good tool for this sort of thing, making class diagrams. The UML is the Unified Modeling Language. It's a de facto standard here of how you can make pictures out of things. And you can make pictures out of anything here, but specifically we want class diagrams here because this relates to code. So a UML class diagram here gives us a picture of a class. So we can see the name of the class, we can see the attributes of the class, and we can see the methods or functions of the class. That's all it is. It's just a picture. So that when I'm thinking about a solution for a given problem, so someone says, hey, I have this problem I need software to solve, I can make a little picture here. And it's not the most interesting picture, but other nerds, other developers will be able to read this picture because everyone does it the same way, and we can look at it and discuss it and say, okay, here's my class, here's how these classes, these are the attributes that they would have, these are the methods or functions they would have, and we can think about, will they work together? What kind of this flow like? There's all sorts of cool UML diagrams you can make, and you can go through and do all sorts of things. So we'll use Visio to draw these in lab. If you don't have Visio, that's okay. I just do it in Word as well. If you just open up Word, you start a new document, and you can insert a table, and you can make a 3x1 table, and you say in the middle here, so this top line is the class name, the middle line is attributes, and the bottom section is functions. And I just do them in Word because that's pretty easy here. There's additional things that go into it, and that's what Visio is nice. You can have arrows, so arrows will indicate inheritance. So I can say, hey, this thing is one of these things, this is one of these things. It's really cool. You can do a lot of stuff with it here. I don't mean to minimize any of it here, but it's just kind of showing this is how we can do some of this the software. So we'll make UML diagrams of our classes. We'll commit our code to the GitHub, including unit tests for 100% code coverage. So there's no exceptions that need to happen here. So I'll show you the exceptions in lab because it's good to know, and exceptions are good, but it was a topic we covered last semester, so I don't want to spend a lot of time talking about exceptions again this semester. We only have so much time, and I don't want to throw the entire kitchen sink at you in a project. So let me build a rubric here for you real quick, because we can put that together. So I need a rubric for project 0. So this goes actually pretty quick here. So we'll have, this is the ship class and tests is 2 points. And then my battleship class and unit tests is 2 points. And my cruiser class and unit tests is 2 points. So 1 point for the class, 1 point for testing it. I don't want to have 10 different rubric things, so is that okay? Can I just do 2 each? And then we'll have the repair ship class and unit tests. And then the Corvette ship and unit tests. Let's do this. Let me do and UML class diagram. We can do this. I want to throw that in. Is that okay? Can I throw that in each of these? So should it be 3 points each then to make life easy? So I don't have to do 2/3 points. We can do that. I can say 3 points. So we'll do 15 total points for this project. Okay, so a point for the class, a point for the tests, a point for the diagram for each of these 5 classes. All right, so we make the rubric. Let's change that. Okay, so 15 total points. What I'd also like you to do when you turn it in is give me a self-assessment. Is tell me, hey, for this item, I got my 3 points. Or, hey, I couldn't get all the unit tests done. I only get 2 points. If that's the case, I'm really hopeful you would tell me before it's due, and I could help you get it done. But life happens. I get it. That's okay. So if you're fine with it, you just, hey, I got 2/3 of it. That's okay. Totally up to you. Ideally, you get 100% because we're going to have 2 weeks to work on this. It's due next. Where's the due date? Right here. 2 Thursdays from today. So you have 2 weeks to work on it. 2:59 is incorrect. It should be 2 p.m. Sorry, because I'll go over the solution. I'll build the solution in class for you. So again, most people find it interesting, I think, enough to watch me do the solutions. I think it's worthwhile because there's several different ways we could go about doing this, and that's okay. Right? As long as it gets the job done, that's fine. And that's what we're learning is the art of problem solving and how we can use our tools to put everything together to solve our problems. Right? There's not just one right way. Now, later in the semester, we'll talk about the efficient way, and most people will argue the efficient way is probably the right way. That's fair, but as long as we're getting the problem solved, that's what I care about right now. We can worry about efficiency in other classes, right? So, yeah, so I'll build the solution out in 2 weeks on Thursday, and we can go from there. So in lab, we'll do some more UML practice. We'll do some more classes practice. We'll do the exceptions practice with our unit tests. It's good to do, but I don't want to throw it in the project. Okay? Does that sound reasonable? Awesome. All right, cool. It's only 2:42. That's pretty good. I think that's about all we got today. So we'll meet up Tuesday for lab first. We'll practice these things, and then Tuesday lecture time, we'll move on to the new topics already. So we will have this project to work on while we're learning new things, and that's just kind of just how the flow has to go. So this will be our first one of 4. So we'll have 4 of these projects before we get to the final project. Okay? Awesome. If you got anything else, let me know. If not, you folks take care. Have a great weekend.